In order to perform a titration, you will need to have the following equipment: a 20 ml pipette, a burette, beakers, marker pens, dropper, stirring rod, funnel, glass funnel, and a small plastic funnel, volumetric flask, and distilled or deionized water. In the example titration that will be displayed, the student will be using hydrochloric acid of an unknown concentration and dehydrated sodium carbonate. By performing a titration, you are able to work out the concentration of a solution that is not known, and in this example, the student will be working out the concentration of the hydrochloric acid. Of course, safety first, so make sure that safety goggles and aprons are worn during the whole titration. Firstly, a primary standard must be prepared using the dehydrated sodium carbonate. As it can be seen in the picture, the solid sodium carbonate is encased in a glass bowl to keep the solid dehydrated as possible. The blue beads at the bottom of the bowl act as an absorber to retain any air present in the bowl. Even though removing the lid of the glass bowl will expose the dehydrated sodium carbonate to a bit of air, it is better to have the dehydrated sodium carbonate already sitting in the bowl before the experiment, as only some of the sodium carbonate will react with the air while weighing. When weighing out an amount of the dehydrated sodium carbonate, make sure that before adding this to the beaker that you tare the weight of the beaker. This ensures that the balance scale only records the weight of the dehydrated sodium carbonate in the beaker and not the weight of the beaker added with the weight of the solid. After weighing the solid, add about 20 ml of deionized water to the beaker and with a stirring rod stir the solid in the water until all is dissolved. It is important to dissolve as much of the solid as possible in order to get accurate results. Once dissolved, pour the solution into a clean volumetric flask by using a glass funnel before filling the rest of the volumetric flask with the deionized water to where it is marked. By using the deionized water bottle, rinse out the beaker and pour it into the funnel. This makes sure that anything that can possibly still be in the beaker is washed down through the funnel into the volumetric flask. Do the same technique with the funnel, as some of the dissolved sodium carbonate can be stuck in the funnel. It is also important to make sure that the funnel is taken out of the volumetric flask once nearing the marked line, as it can affect how much has been poured in. A dropper can be used to ensure that the bottom of the meniscus is just sitting on the marked line. Place the lid of the volumetric flask on with your thumb covering the lid, carefully shaking the volumetric flask to make sure that everything in the flask is well combined together. Marking your equipment is essential when performing a titration, as there can be many different solutions that can look like water. Therefore, after shaking the volumetric flask, label it. To be more efficient when performing a titration like this, label the volumetric flask and what it will contain inside before doing anything else. Leaving the now filled volumetric flask to the side, pour a substantial amount of hydrochloric acid, of which the concentration is unknown, into a beaker and label the beaker straight after. Before using the hydrochloric acid, the burette must be rinsed with deionized water just to make sure that the burette is clean from impurities. To clean a burette, the tap nozzle must be closed, and it is closed when the handle is facing horizontal. The tap nozzle must be closed as this prevents spillage of the hydrochloric acid. It is best to do this part over the sink to further prevent the risk of spillage. Once the burette is filled to the top and the bottom of the meniscus is touching the zero mark, carefully attach the burette to the retort stand as it is shown in the picture. Using a clean pipette, rinse the inside of the pipette with a bit of the sodium carbonate solution that is inside the volumetric flask. Place a rubber bulb at the top of the pipette, making sure that it only covers the tip. Depending on what rubber bulbs are available to you, press the A button while squeezing the rubber bulb to suck in air. While the rubber bulb is in this shape, place the pipette into the volumetric flask and press the letter S to suck up 20 ml of the sodium carbonate solution. It is important to make sure that the bottom of the meniscus is sitting on the marked line on the pipette. Then, after obtaining exactly 20 ml of the solution, release the solution into a clean conical flask, clearly labeling it after. Before placing the conical flask underneath the burette, it is very important to add the indicator, as through the color change we are able to figure out roughly where the end point of the titration is. In this example, the student will be using 3 drops of methyl red that will turn the solution into a pink color. To begin the rough test of the titration, position the conical flask underneath the burette, making sure that there is room for a swirling action. When ready, turn the tap nozzle to a vertical position and gently swirl the conical flask while the acid is dropping into the flask. The end point is reached once the full solution turns into a definite pink color. The lighter the color, the more accurate the titration will be. As this was the rough test, it will not be counted in the final calculations. Using clean conical flasks, repeat the process of obtaining 20 ml of the sodium carbonate solution and mixing it with 3 drops of indicator while continuously refilling the burette back to 0. Record your results and calculate the concentration of the hydrochloric acid.